All right, question number 15. We want to use the graph of f prime and f double prime to find the critical points and inflection points of f, the intervals on which f is increasing and decreasing, intervals of concavity, and then we're going to graph it assuming that f of 0 is equal to 0. All right, so I'm going to make this full screen so we can see it a little bit better. From this graph, it looks like the pink line is f prime, blue line is double prime. Okay, so if you have the definitions next to you, you can go back and look them in the textbook. Basically, we want to find the critical points. So we're going to find the critical points whenever we find the derivative and set it equal to 0. Okay, so the red line is our derivative. It is 0 at 1 and 3. So our critical points would be 1 and 3. All right. Next is going to be our inflection points. Our inflection points are going to be points where we take the second derivative and set it equal to 0. So when it changes from positive to negative, okay, we're going to have a change in inflection. So this blue line, our second derivative, it is 0 at the number 2. So we're going to have an inflection point when x is equal to 2. All right, intervals on which f is increasing and decreasing. So when you find the derivative, you plug in values. When the derivative is negative, it's decreasing. When the derivative is positive, it's increasing. So when this red line is below the x-axis, it's negative. So this is negative from 0 to 1. And then it's also negative from 3 to 4. And then it's going to be positive from 1 to 3. So we have two decreasing intervals and then two increasing, or one increasing interval. So decreasing from 0 to 1 and also decreasing from 3 to 4. And then it was increasing or positive from 1 to 3. All right, the next part, we're going to find the intervals of concavity. When does it concave up? When does it concave down? So concavity is dealing with the second derivative. So when the second derivative is positive, so this blue line is above the x-axis, it is concave up. When this blue line is negative, below the x-axis, it is concave down. So it is concave up from 0 to 2. And then starting at 2 to 4 is going to be concave down because it's below the x-axis. Opposite of what we see visually, but the property says whenever it's positive, and we're looking at the value. So concave up from 0 to 2, and then concave down from 2 to 4. All right, and then we're going to graph it assuming we start at 0. So when we're at 0, we're equal to 0. So we are looking for a graph that is going to be decreasing and then increasing and then decreasing. When it's decreasing, it's going to be concave up, and then it's going to be increasing through that interval, and then it's going to go to concave down, and it'll start decreasing. So we're going increasing, decreasing, increasing, starting with a concave up. So we're decreasing here. This is also decreasing concave up, but it doesn't decrease the whole time. This one goes decreasing, concave up, and then we have an inflection point, and then we're increasing, and then we have a concave down part. So this one looks to fit This one starts out increasing first. We know we need to start out decreasing. So just based on the start, I would eliminate A and B. These two graphs start out decreasing. This has a concave up and a concave up. We need a concave up and a concave down. So D would be the best graph.